Dear students, I am Nilanjana Sanyal. Welcome you all to my channel NS Online Math Classes. Our today's topic is the division law of logarithms. And e is greater than 0, e is not equal to 1, x is greater than 0, y is greater than 0. You will be knowing about these e, x and y very soon. What do they represent? You will be knowing about them very soon. Okay? So without any further delay, let us start with our today's session. First of all, let us look at the division law of logarithms. It is log of x over y to the base e equal to log of x to the base e minus log of y to the base e. And since e is in the base of all the three log terms, e should be a positive number and e cannot be equal to 1. And this is the restriction for the base of any logarithmic term. And if you are not familiar with the restrictions of the base of any logarithmic term and the restrictions on the arguments of any logarithmic term, then I would definitely be asking you to watch my videos. There are in fact two videos, one on the restrictions of the base and the other is on the restrictions of the argument of any logarithmic term. Okay. So this is the division law of logarithm. And now, coming to the argument part, x is greater than 0 and y is greater than 0. The argument has to be a positive number. You see, even if the x and y, even if both are less than 0, x over y will be a positive term. But we cannot take x less than 0 and y less than 0 because these two terms will then be having negative arguments which cannot be taken. Okay, so x should be greater than 0 and y should be greater than 0. Now coming to the proof part. We start from the left hand side. It is log of x over y to the base e. And this can be written as log to the base e, and in place of x we write e to the power of log of x to the base e. And then there is this division sign, and in place of y we write e to the power of log of y to the base e. X can be written as e to the power of log of x to the base e. And if you are again confused with this part, that how can we write x equal to a to the power of log of x to the base e, I would definitely be asking you to watch my video on 4 important properties of logarithms. Over there I have explained why these two are the same. How can you say that these two are the same? Okay? You can write x in this form, a to the power of log of x to the base e, and y in this form, e to the power of log of y to the base e. And now we will be using the division law of indices or exponents. It is e to the power of m divided by e to the power of n, which will be equal to e to the power of m minus n. So this is equal to log to the base e, and this is e to the power of log of x to the base a minus log of y to the base a. And this is another property of logarithm where the argument is having e to the power of something. It is in the exponential form, and this base both are the same. The base of the argument and the base of the log term, if both are the same, then the value of this log term will be equal to the power. So this is equal to log of x to the base e minus log of y to the base e, which is the right hand side of this law. So we have proved the division law of logarithms. But this is one of the forms of the division law of logarithms. We will be knowing about the other form as well in this very video. Okay, so let us look at the second form. It is just written in the opposite order. The right hand side two terms are written first. It is log of x to the base e minus log of y to the base e equal to log of x over y to the base e. You need both the forms because sometimes you are given a single term and a single log term and you have to get two log terms out of that single log term. That time, if the argument can be expressed in this form, something divided by something, then you can use the division law of this form. And in some other time, you may be needing to express, there may be two log terms connected by this minus sign, and you may be needing a single log term. So you should be expressing these two log terms in this way, log of x over y to the base a. So both forms are needed. And now let us look at the proof of this form. And we start with this log of x to the base a, then we will be going to log of y to the base a. So log of x to the base a, let this be equal to p. This is a logarithmic equation, so its corresponding exponential equation will be e to the power of p equal to x. And I am not saying the BAP and BPA, all these things anymore. We have learnt enough of BAP, BPA, and again, if you do not know how to convert the logarithmic form to exponential form or exponential form to logarithmic form, I would definitely be asking you to watch my videos on this topic. Okay? So, e to the power of p equal to x. And now we come to log of y to the base e. Let log of y to the base a be equal to q. So this is a to the power of q equal to y. So we take the left hand side, log of x to the base a minus log of y to the base e equal to p minus q. Okay. Then we take the exponent. We take these two as the exponents of a. So it is a raised to the power of log of x to the base a minus log of y to the base a, and this is equal to a raised to the power of p minus q. So, and now we use the division law of exponents. So a raised to the power of p minus q can be written as a to the power of p divided by a to the power of q. What is a to the power of p? It is x, and a to the power of q is equal to y. So it is basically x divided by y, which is equal to x over y. Okay. So a to the power of log of x to the base a minus log of y to the base a equal to x over y. Next we take the log to the base a of both the sides. We have log to the base a, and this becomes the argument of the left hand side, and it is log of log to the base a, and the argument is x over y for the right hand side. And again we are using this property that we have used over here, property of logarithms. When the base of the exponential part of the argument and the base of the logarithmic term, when both of them are the same, the value of the logarithmic term is the power. So it is log of x to the base a minus log of y to the base a equal to log of x over y to the base a. And this is the division law of logarithms written in this form. Okay. So we have proved both the forms of the division law of logarithms. Now we come to one of the example questions. We will be using this law in solving many other questions, but this is just an example question. Write log of 6 to the base 5 minus log of 3 to the base 5 as a single logarithm. Both are having the same base. This is important because we are having the same base a. We are having the same base throughout. It is the base a. So this is important. The base should be the same. And when the base is the same and the two log terms are connected by the negative sign, what do? It is log to the same base 5 and the arguments get divided. It is the first argument divided by the second argument. So it is 6 divided by 3 or log of 2 to the base 5. This is the answer. So log of 6 to the base 5 minus log of 3 to the base 5 is equal to log of 2 to the base 5. Okay. So students, this brings us to the end of this session. Please like, share and subscribe if you have found this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.